Okay, so I guess we are live now. Want to welcome everybody to this live stream. It's really exciting to kind of show off this new feature that we are releasing from CircleCI to our developers. This feature is released in preview, and it was a feature that was been requested by many people in our community to enable the ability for developers to now include ARM architectures within their CI/CD pipelines. And today I have a guest with me from our product team here at CircleCI who has devoted a lot of time and energy into providing this feature to the community. So before I introduce him, I'm going to bring him in. It's my buddy Alexey Klochay. Did I say that correctly, Alexey?
Yep.
Well done. All right, awesome. Cool. So yeah, my name is Angel Rivera. I'm a developer advocate for CircleCI. I'm sure some of you who've watched this stream have seen me. I haven't been on here in a long time, but super excited again today to be announcing and showing off this awesome new feature that Alexey and our awesome engineering team have been working on for so long to be able to provide this feature. So today we are announcing, and Alexey, correct me if I get this all wrong, but our new feature, which is called ARM Compute Resource Classes. Is that right?
Or ARM Resource Classes, yes.
ARM Resource Classes. Okay, cool. Yeah, I was told by some of our marketing people it's ARM Compute, whatever. So it's all good. But yeah, at the end of the day, the results are we now have the ability to build pipelines on ARM infrastructure and architectures, and that is something that's very well sought after, right, by the industry and by our customers and developers. So, Alexey, before we get into it, I wanted you to introduce yourself and who you are, what you do, fun fact at CircleCI.
All the good stuff. Thanks so much, Angel. So my name is Alexey. I'm one of the product managers here at CircleCI. I work with a team called Fleets. We are part of the domain that takes care of all the compute fleets that we run for our cloud product, which includes ARM, but also other compute resources, including the Docker Executor, the Machine Executor, kind of everything that runs customer jobs in our cloud product. And so I'm based in Berlin, Germany. It's around 7 p.m. here. The sun is still up, which is amazing. Thanks, daylight saving time. My fun fact today is I actually went to musical school for around 10 years, and my instrument is a vibraphone.
Wow, I did not know that about you. So interesting. I guess I should share a fun fact as well, right? So I forgot to do that. So my fun fact is I used to live in Iceland and did a lot of work in the EU, and it was a great place. I still have close ties to Iceland, so I'll be returning there this summer.
I spent quite a little bit of time in Iceland at some point. It was actually my first year at CircleCI in 2015, and it was glorious.
Oh yeah,
absolutely.
Where in the Reykjavik?
Yes, in the place. Yes, just wonderful memories all around.
Talar þú íslensku?
No, sorry, no.
Pínulítið? No? Oh, okay. Sorry.
But well done. Amazing.
Flexing my Icelandic on you a little bit, which is pretty bad actually, but we tried. Yeah, no, it's a tough language to kind of get a hold of, especially I learned it through attrition, right? Because I worked with software developers for so many years there. So, but no, it's a great place, and looking forward to going back. Great, nice. Man. So, so now that we kind of covered who we are, what we do, I can tell all of you that Alexey he's got his hands in a lot of our feature sets, a lot of development and innovations that we're doing. But the fact that he works on the team that he works on, which is the Fleets team, that's one of the, I would say, in my mind, more difficult teams to work on, because what we're doing there is essentially ensuring that the CircleCI platform has enough capacity, right, to run jobs. Is that right, Alexey? And orchestrating that is very difficult, as you can imagine, at scale.
Yeah, that's exactly right. So basically what we try to do is, running your own compute fleets is work, right? It's just work that folks have previously had to do on their own. And we are here basically to try and do that well at scale. So kind of make sure that everything runs to completion, make sure that everything runs on the type of compute that was requested, right? Making sure that everything is available, and the team is investing, kind of my team as well as the sister team on that is helping on some other pieces there, investing a lot of time into making sure that everything is stable, consistent, and all that.
And reliable.
Reliable, right?
Yeah.
All while investing in building out all new compute fleets, right? Because we're excited to support ARM now and kind of lots of other stuff.
Yeah, no, like I said, this is it's a very important, critical team for CircleCI. Not that any other team is not as critical, but it's one of those hard working teams, right? I would say not the use case, but the responsibility that you all have is, and I want to highlight that because I know, coming from an operations background, how difficult that is just to support an application. Imagine supporting, hundreds of thousands of folks, millions of builds per day. Having that infrastructure up to do that, it's just not an ordinary task, right? For any ordinary human or company even. So, props to you for keeping that, for innovating there, and also the operation. All right, there's a whole slew of people, but it all starts with that underlying infrastructure. So that's a great segue into kind of like the ARM preview overview. Like I mentioned, we're announcing this today. I actually wrote a blog post, which I could probably share when maybe Alexey was going into a little bit more of an overview. I'll do that. But basically, we're really excited to kind of talk about this release and what it is, how it works, and what we'll do is have Alexey go into maybe a little bit of a discussion around the actual use cases, like why did we build this, Alexey? Could you share some insights into that?
Yep, absolutely, and thanks so much for all the background up to here. So the basic idea is we really try to enable our customers to run the jobs on the architectures, on the types of compute that they really care about, right? And so far we have a fairly extensive catalog of things that we can do on our cloud environment. And one of the things that has frequently been requested is ARM, right? So customers want to be able to build and run ARM-based Docker images. Customers want to deploy to ARM infrastructure, like AWS's Graviton 2 instances, right, and a bunch of others. And then the ARM architecture overall, right? This is something that has been around for a while, right? So it's the core of many of the mobile devices that we use, in day to day. But as a server architecture is something that's, you could say, relatively new, right? It hasn't really been gaining mainstream adoption until recently, right? And so in the past couple of years, we have seen some servers with providers like Packet.net now, part of the
Equinox Metal.
Exactly. Part of that offering, they had really interesting ARM servers early on, right? And then AWS also introduced the Graviton 2 family, which is kind of much more interesting for general purpose server workloads compared to Graviton, the original one. And kind of some customers, many customers right on AWS who are also using CircleCI are seriously considering or already migrating some of their Intel-based workloads on ARM, right? The main reason for folks to be going in that direction is just kind of cost of compute per unit of performance, effectively, right? So you're able to do the same amount of work for either faster or at a lower cost, right? Which is a very valuable proposition for many customers. And so what we have been seeing is, as folks are starting to get more interested in all things ARM, the support of ARM in the CI/CD environment that they're using is crucially important, right? Because if you are using CircleCI to deploy to production, build and deploy to production, kind of important, right, to test on that target architecture before kind of you start pushing things out. For many organizations, this has also been like the first step of experimenting with ARM. How do we know whether this is going to run on ARM? And we've had some internal projects that we had the exact same problem with, right? How do we figure out, how does this run on ARM right away, or kind of what do we do, right? And so the first step is, just set up a CI pipeline, add a build target that, builds for this platform, see if all the tests pass, see if everything works, right? And then try deploying it into a staging environment, doing more testing, and then try and go into production. So what we're trying to do here is basically to enable folks who are ready to start adopting ARM, right? If you kind of are, as a customer, if you are looking at using ARM compute today on the server side, right? We want to make sure that you have access to those resources on the CircleCI side, just to be able to test and build and test for those platforms.
And that's a great point that you've raised here, because I think, ARM has been around for a very long time, right? This architecture is not new, but there may be some confusion as to kind of the offering that we're providing. So, I know from my experience that a lot of IoT devices may use some form of an ARM architecture, right? As far as hardware, what we're providing, right, is not that, right? It's not an IoT like device capable or testing environment right now. I think that's a really hard problem to solve for anyone. Even the ARM people have problems solving those, right? Because of a physical kind of context, right, for those IoT devices. Can you tell us like what version of ARM, what exactly we are offering in a more technical sense, just so that folks are clear on this? Because like when I see ARM, I see right now I think of Apple, but before that I thought of IoT devices, like I don't know, maybe temperature sensors or controller boards, things like that.
Definitely. So to be kind of really specific on this, so what we are supporting today and what we are what we have announced in preview today is the support for the 64-bit architecture of kind of server-based architecture, which is ARC64, or this is the V8 version 8 instruction set of the ARM architecture. Effectively, the main purpose of these chips has so far been in ARM servers, right? So this is the architecture that's being used on AWS's Graviton 2, for example. This is the architecture that's used on the most recent servers that Equinix Metal is providing, for example, and kind of all the other kind of server providers. We are current at the moment. This is Linux only, right? So we are talking about ARM on Linux, and we are definitely interested in going further on other platforms beyond that.
Yeah, I think as people start adopting, right, the ARM architecture, just having a way for developers to kind of extend their application to those architectures is a really huge plus, in my opinion. When I was actually on teams and trying to build things for other architectures, which happened quite often, it was like to incorporate something like that into our CI system was like jumping through hoops, right? Like we had to stand up either virtual machines with the hypervisor, right, for that specific architecture, run our tests, then kind of just maintain those VMs or keep them up to date. And by the way, just emulating all that doesn't really get you 100% there either, right? So it was an emulated environment, which for the most part, probably 98% of the way got you what the results you needed. But there were some differences that the emulators were, running bare metal versus emulation. There's always some variance there. So yeah, no, this is really exciting, especially as a technologist. So you know what? I think we kind of covered all the bases on some of the differences. What I'd like to do now, Alexey, is go through a demonstration, right, of how people can actually implement this into their CI/CD pipelines. So what I prepared is a code demonstration. As I mentioned earlier, there is a blog post that has been released today as well. So some of this will be covered in the post, but the post kind of generally gets you where you need to be. But I like to do things a little extra, right, to kind of demonstrate in a more practical sense how to implement this stuff and use it. So let me go ahead and add some code to the screen, or at least let me add my screen to the stream. That's that's a mouthful. So let me go ahead and also get rid of some of this ugliness as far as like the logos and stuff like that, or move them around somewhere. There we go. And then we'll get rid of, so I'm actually producing this as well live. All right, cool. So that looks good. So what I'm showing you here is a project. Let me give it a little, how's that look, Alexey? Is it
looks good? Yeah, this size is great, I think.
All right, great. So yeah, what I have here is a project. This is based off of some of the code in the blog post. You can go to CircleCI public on GitHub, and there's a repo called ARM Executor that's linked in the blog post. But this is a separate project I'm showing you, one of my kind of test projects that I use for development. And what I'm going to show you is basically the configuration. So well, let's talk about the application or the demo. It's just a simple Node.js application. It has all the bells and whistles for a demo app. But what I'm going to demonstrate here are a few things. Obviously, implementing the ARM executors into your CI/CD pipelines, right? So I'm going to show off how to, what a ARM enabled or an ARM capable workflow or pipeline looks like. I'm also going to demonstrate how you can, build, test, and deploy a Docker image based off of an ARM, architecture, and deploy it to an AWS ECS cluster built on Graviton 2, which is the ARM architecture nodes, right? So end to end, I just wanted to demonstrate like the whole ARM experience in your pipeline and then also in your deployment environment. So yeah, let's start with I guess the config file. So obviously, right, this is let me collapse all these things here so we can kind of go over some of this stuff a little bit more reasonably. And as we get to things, we can show exactly what we're talking about. So first thing I wanted to show off here is the fact that we're using CircleCI Orbs. These are basically packaged configuration. And what it essentially does is provides you centrally managed functionality that's reusable within your CI/CD pipeline. So think of it as if you're comparing it to like a programming paradigm, object-oriented programming concepts, right? Where we're encapsulating functionality and then making it reusable to your CircleCI configuration. And again, right, this is just for folks who haven't really used the Orbs feature before. What I'm doing here is setting up an Orb for our nodes. It's a node application. That way I can have the Orb do a lot of functions for me without having to declare a lot of things. This is also great for reusability within your YAML file, and it's designed to also lessen the amount of syntax within your YAML file, right? So if you have a lot of repetitiveness previous to Orbs, you would have to cut and paste and change one value. But with Orbs and pipeline parameters, you're now able to kind of lessen a lot of that syntax and keep a nice, concise, tight config file. So the first thing I want to address here is what we call pipeline configuration or pipeline variables, I should say. And what I've done is created a commands key here. So in order for us to deploy our ARM-based or ARM-capable application, we need to create some infrastructure, right? And one of the ways I do this is by leveraging a tool called Terraform, which is an open source project from our friends over at HashiCorp. And what I've done here is created a mechanism to download the binary specifically for ARM, right? So if you're using an ARM or a Linux AMD 64 version binary on an ARM platform, like we're going to show you, you're going to get errors, right? Alexey, I'm sure you've seen this many, many times where it's like, yeah, it's not going to work. It doesn't know the instruction set is different, doesn't know how to talk to the processor, right? So we have to first download the binary for the ARM specific, right? But I wanted to kind of reuse this format within my CI/CD pipeline. So what I've done is created a variable or a parameter called install Terraform. And essentially what it does is it enables me to create these parameters, right, of the things. I can define the properties, like this parameter is called version, right? You can tell it's a string. You can even set default values. So with Terraform, you have to be careful, because if you create infrastructure with a previous version of Terraform, you're going to get like an error from Terraform saying, hey, it's not backward compatible. So, this is just in a way to kind of control that. And then I have an architecture variable, right? Or a parameter that enables me to kind of tell it like, what to download. And if you look down here, it's simply just a command, right? Like no different than any other command that you would run on a pipeline. What I'm doing here is just changing into a temporary directory, using a wget call, right, to a specific URL, and then I'm basically making the bits that I need to have, or making the bits I need to be flexible. I'm using the parameters, right? So this is actually a parameter. This is how you would instantiate that in your call, right? So I'm replacing those values in the HTTP URL, just building out that URL. As you can see, right, there's a lot of parameter version being used, and then here's the architecture, right, for the naming of the file. Once it hits downloads and hits my temporary directory, I'm then able to go ahead and unzip the file, right, and then move it over to a location on that executor. Now, currently, Alexey, the executor type that we're running ARM on is currently what? Machine only at the preview point, right?
Yeah, that's exactly right. So we have started with the machine executor. So what we are currently offering is all the customers on our usage-based plans, which includes the free plan. Also, they get access to the machine type ARM.medium, which is a VM with an ARM CPU and a bunch of memory and a bunch of disk space, right, that you can use for this. And the customers in our performance custom scale plans, they get access to the ARM.large executor, which is the same, just twice the size. And these are all VMs. So basically, we create a dedicated environment for the build, right? An isolated virtual machine. Then we shut it down and destroy it securely after the build is finished. The other kind of popular option on our platform, which is currently not supported for ARM, is the Docker executor, where you build literally in a Docker container, right? But that is something that we are definitely interested in and are collecting feedback on our ideas website, which we can link here at some point.
So Alexey, we got a little bit of a hello. Hello, I'm
Hello there. How's it
nice
going?
to meet you. Oh, I forgot to mention too, I'm so sorry. If you have any questions or comments, please post them into the sorry, I got somebody interrupted me here. Into the comments section. We're here to answer your questions and also like listen to your feedback. Definitely down to if I see anything, I'll definitely address it. So yeah, please don't hesitate to kind of ask questions. That's what we're here for. So yeah.
Absolutely.
So let's go ahead and talk about. So okay, I addressed the URL. So essentially, what I'm doing here is just building a mechanism to download the appropriate URL, right? And again, this is a construct that is designed to be reusable, and you'll see this is the definition, by the way. So it looks a little bit lengthy and wordy right now, but that's okay, because this is the definition of my pipeline variable. Let me move that out of the way, and I'll show you the implementation now in the jobs section, right? So again, I created a command, a generic command with the name of install Terraform. And then I created two parameters of version and architecture, which then goes ahead and helps build a URL for that specific architecture retargeting, and also performs a bunch of unzip and installation processes for that binding for Terraform, which again is required for some of the other jobs that you're going to see here shortly. If there are any questions right now, I'll give like a few seconds for people to ask before I move on. All right, if you have any questions, just go ahead. We'll keep it moving. So let's see. First job, right, is basically a simple run and test, right? As all good developers should be doing, we should be running some form of testing on our code and our CI/CD pipelines, right? So the first job I always like to create is a run test job. And what I'm showing you here is, again, right, a simple job label of run tests. This is where we actually start implementing some of this ARM magic, right? We're setting a machine executor type. These vary, like Alexey said, from machine, which is a full-blown VM you get. It could be a form of Docker, it could be in the form of Mac OS. It could also be in the form of Windows, right? But we're going to use just a machine image, which is kind of the standard for basically our Linux offering. Is that right, Alexey?
Yep.
Yep. And then we have to define an image, right? So what operating system to install and run, which is what this key stands for. If you had a Docker image, you would also provide a Docker Docker image, right? In this as a value. We're using an Ubuntu 20.04 instance or operating system. And then here's where you actually define, right, the ARM or instantiate an ARM, define and instantiate an ARM executor. So it's just that simple, right? Just adding that resource class, adding that value of ARM dot medium, and I think large is what we're supporting right now because it's our preview to the feature. We're building this out, so we're trying to be very proactive and enabling or giving folks access to this stuff, and you can use it, give us some feedback. I know Alexey is very, and his team are very interested in feedback because we want to, evolve this feature and make it super useful and valuable for the community. So definitely, hit Alexey up. I'm not sure what the feedback mechanisms are. We didn't even discuss how you can kind of register, right, for this. Is that still a thing, Alexey?
Yes, exactly. So the easiest way, I was going to interrupt you for a second, but it's great that you're mentioning. So if you go ahead and specify the resource class and put in arm.medium, unless you have already requested access to the ARM preview and you were we approved your access, you will see an error when you try to do this. So what you need to do is to go to our documentation page and just search for ARM in our docs. We will paste in the specific URL in here so that you can just go straight in there. But there's you can go to our docs, go to the ARM page, and then click on the contact form, basically. Fill out the details, fill out the organization name that you will be using this under, and we'll get you right in. So right now, we try to turn around the request for ARM access very quickly.
Yeah, they've been pretty responsive. So I think in that blog post that I mentioned, that there's also links to all of this stuff, right? So please check out the CircleCI blogs. There's a lot of other cool information there as well, but definitely check that out. And I will share the URL, I guess, a little bit later. So great. Now that so again, to reiterate what Alexey said, please reach out to your reps or just make an inquiry to CircleCI. We can point you in the right direction if you don't find the resources, or you can hit me up at punkdata on Twitter or comment here. We'll get you what you need. So let's go ahead and talk about resource classes. So again, we have the medium and large offering, and that will evolve, right? So this is again the beginning. This is a preview kind of go-to-market launch. So we will probably have a general availability launch. Is that right, Alexey, later on? So that once the product evolves and we get it to a very cool state.
Yeah, exactly. Our goal was to gonna start allowing access to this as soon as possible. So we are already using this for our own work that we do. We already have a number of preview customers that have kind of helped us validate this, and if anyone from the preview folks, early preview folks is watching, thank you so much for coming in and providing feedback for us. That was super helpful. And we're looking forward to getting more feedback on this. And you can always go to our Discuss website, so discuss.circleci.com, and provide feedback there on all things ARM, as well as any other issues that you have with the platform. You can always surface them and get help on that front. Yeah,
and also we have a Discuss site as well, right? Like for our community base. So please hit that up as well. And we also have a Discord I need to get all those links. So at some point I will have them for you all, and I will post them online here, and you can ask questions in there as well. So now that I've created, so let's get back to the config. This is pretty awesome. So I created a resource class. Basically, right, it's a job, so we need to do some things, which are a list of things in our steps. A key here, first thing, obviously, we always got to get our code, right? So we got to do a quick checkout of the code that has changed. And then here's where I'm using this node orb. Remember when I mentioned we are using the node JS orb? The node JS orb this is how you instantiate the usage of it, right? So we have a key named node. We're using that here. And then this / indicates some function, right? Something or parameter that's available within the orb node, the node orb, I'm sorry. So what we're doing here is basically installing our packages, which is essentially running an npm install, right? So this is a parameter, and I'm telling it, hey, run this command for me. Also, the nice thing about the node orb is that it actually has a caching mechanism that you can leverage, right, within just one line. If you were to do this caching process without the orb, it would require a couple more lines of code, which, again, we're trying to streamline the process. So it's a very handy tool to have when you're using that node orb, the ability to do things like, create a cache and not have to worry about the other steps that, other steps that would require more lengthy definitions within your pipeline. So again, right, orbs help to streamline that functionality. So it kind of just pushes that functionality to the back, which is where the actual source code is, and the users don't have to really think about it, right? So it's a really nice feature, and it's a lot of our node orb users are super happy about that functionality. So the next step here, right, is I'm going to run my test, right, and essentially just run my, I'm using a Mocha framework for my testing. And this is how I like to kind of kick off my test. And then what I'm doing here also is telling Mocha to not only, run my test, but I'm also telling it to create some reports for me. And as you can see, right, it's a report directory, which is called test results, and then a report file name, which is also called test results. And then if you move down to the other key here, another command, right, it's store test results. And I'm just telling it, hey, store it in this directory. And I'm also storing the artifacts. I know for a fact that this store test, this one here, has a little bit of issues, so it may not work. Or actually probably more than likely won't work, but that's okay. I still get the artifact results here. Now, now that we kind of covered the run test breakdown, and everything's clean, right? So my test should run clean. I want to build a Docker image so that I can then deploy this release of this application. Again, because I'm, the way Docker works is it's not like a conventional hypervisor, right? Where a hypervisor will emulate the kernel that you're targeting. So you could actually build an ARM 64 V8, perform or create a VM or operate a VM for ARM version 8 using a hypervisor and emulator technology in a Linux 64 AMD 64 architecture, right? So again, with the hypervisor, you're getting that emulation. But with Docker, the way that works is it shares the kernel. So the underlying host kernel of that Docker host, if it's Linux, you're not going to be able to do this, right? Unless you're running Docker inside of an emulated ARM 64-bit compute. So with the build Docker image, our Ubuntu image already has Docker installed, and it's the binary for the ARM 64 architecture. So that's okay. We don't need to download like we did with the Terraform, right? The image doesn't come with Terraform installed. So, but Docker is installed. So it's easily, I don't have to, that step is skipped. So what I do here is essentially just run standard, like, building a Docker image name based off of CircleCI environment variables that are included natively. And then I'm just, running my old Docker build commands to build an image. In this case, I'm tagging it with a couple of things. One is for the latest build, and then this one has a pinned version, which ties to. Let me undo that because that was not intentional. But what happens here is I'm creating one with a pinned version, which I'm using the pipeline configuration number, right? So it kind of ties that release to a pipeline number. You could actually name this however you like. This is like the way I like to do it, so that I know, hey, pipeline number, whatever is tied to this release. And then finally, right, I do a quick Docker login, and then push my code once everything is good. Now, once that image is built and pushed, the next step here, this is where it gets interesting. We get to actually create some infrastructure, right, and deploy this. So again, I'm going to leverage the ARM, 64-bit resource class. And in this case, I don't have Terraform installed. So I'm going to have to, download the appropriate binary. And that's where, if you look here, I created this, parameter, pipeline parameter, or pipeline variable. And it's called install Terraform, right? So this definition up here is where all that action lives. And if you can look in the implementation, which is here on line 67, it's simple, right? To install, to implement, just give or define or specify the variable. Go ahead and fill out the parameters. In this case, I want to use version 14.2, and then the architecture is ARM 64. Now, I didn't have to add this value here because I already defaulted to ARM 64 up here, but I just wanted to show you the full effect of this. So yeah, great. We have hopefully our pipeline will execute this, install our Terraform, and then we can proceed to the actual deployment, right? So let me open up this. If this is infrastructure as code, what I'm showing you now. So this is a way to build infrastructure on cloud providers. In this case, we're going to be working with AWS, and we are building an elastic container service, which is, I would say, like Kubernetes light. Does that sound right to you, Alexey?
It's Kubernetes with kind of significantly less work, or like the similar experience, right? With significantly less work. Is that completely fair?
It's designed to help developers kind of deploy infrastructures without all the complexity that surrounds Kubernetes, right? Kubernetes is a great platform, but it is a more complex platform to deploy and also manage, right? I think deploying it's the easiest part. Getting it up and running and managing it is one, it's a task. It can be. So anyway. Amazon has a great service there. I actually used this in production in a former life, and I really enjoyed it. So, it has its good points and bad points, like everything. But today we're going to use this because I really like the service. Obviously, we're going to CD in because you have to run this in the current run Terraform scripts in the current directories, right? And if you're familiar with Terraform, you have to initialize it. So all that means is it has to download all the providers and plugins that you're using. And then finally, this is the execution, right? So this is actually the kind of like the trigger to tell Terraform to build infrastructure. As you can see, I have some variables defined. These are internal to Terraform, so that within the code, I can give some variability to some values that need it, right? In this case, my Docker image and my Docker image tag, I would like to keep them flexible. And then finally, this auto approve is basically telling Terraform, because if you don't have it, it will expect an interactive response. This is bypassing all that, right? So auto approve means don't prompt me for anything. So once I have that up and running, you're going to have an ECS architecture deployed on Graviton 2 instances. Let's jump into the code real quick for Terraform, just to kind of show it off, and then I'm going to kick off a demonstration. So on the back end here, I like to use Terraform's state organizer. It's called Terraform Cloud. So once you deploy infrastructure, it will maintain a certain state, right? So your infrastructure's code needs to remember what it deployed, and how it's configured. And that's what state means in Terraform, is basically the current state of your application or your infrastructure that was deployed with this code. As you can see here, I'm just using AWS. And then there's a couple of things. I don't want to go too far into it because there is a lot of things going on here. But as you can see here, remember those variables I was talking about, Docker image, Docker tag. If you look here, they are here, right? So that's what I'm doing is basically kind of injecting values into my Terraform code using these variables. And yeah, and then as you can see as well, I'm defining some roles. So I'm actually, this is going to create a virtual private cloud. It's going to create security groups. It's going to create my security roles, right? So creating a roles-based identity for my service, not an actual user, but for the service, so that the service can assume certain permissions, right, to execute in Amazon. You need the rights and privileges to actually do things. Once that's complete, I'm actually going to create an auto scale launch configuration so that my cluster will auto heal or auto be a little bit more resilient, right? So if they're having an issue with one of the machines, maybe ran out of memory or there's some hiccup with Amazon, it will basically stand up a new machine for me and then destroy or terminate the underlying architecture or the node that was causing problems. So right, with Terraform, right, I'm creating a whole experience here, a whole infrastructure with scaling policies as well. So like if anything changes, like maybe my CPU is at capacity, I have a policy here that says, all right, if there's any unhealthy nodes, just build a new one and then terminate the old, right? So replace things. And that's what the autoscale group does, is gives you the ability to either scale up or down based on the on some rules, right? In this case, I'm changing the capacity if there's a couple of things like alarms right here that I'm defining. In this case, I'm looking, I think, at network output. So if my server is, not providing, or my server is, or my node is pushing out too much traffic and it's not being able, the capacity is too high, this will add another node to the cluster and then increase the capacity, right? So then that threshold will be balanced amongst all the nodes in the cluster. I'll jump down to the other bits here. These are really not that important, but basically this is really important. This is an application load balancer, so I'm creating a load balancer as well in this, so that the service that I'm providing is my ECS cluster is available to the public internet on port 80, right? So, and it's also load balanced, so that means the traffic is evenly distributed and handled right across the board. So there's a lot going on here, but I don't want folks to be super intimidated. And also, this code is available. Again, you can look at it, play with it, and instantiate it, and ask questions later if you like. So once all that is established and deployed, we go ahead and deploy the ECS service, right? So here's where we're creating the cluster, and then I'm deploying the service, which has a lot of definitions based off of things we did earlier, right? Like what Docker image to deploy, and also, what load balancer to use to accept the traffic on. So that's kind of Terraform in a nutshell. I don't want to get too far deep into it. We can have conversations about that later. But if you have any questions, please ask them. I'm more than happy to engage. So I think, Alexey, I showed off a little bit of all that, right? What the pipeline will do. But what I'm not happy with is this mechanism up here, especially, right? So I created this commands parameter, which is totally legal and acceptable, right? But we do have orbs that can kind of help with all those issues, right? And give us a cleaner way to do these things. We recently upgraded our orb version to version 2.0, which actually added this capability that you're seeing here. So the ARM capable installation in the orb is possible, and in the Terraform orb, I should say. And also, we do have a Docker orb. So like if we go back to building my Docker image, this isn't a lot of code, but it is nice to have, kind of centralized capabilities or management of building these processes, and also maybe even also guidelines. So before we jump into like executing this, I want to change it. I want to change it so that I'm leveraging orbs instead of this manual process that I'm doing here. So let's go ahead and I do have a branch ready to show off some of that. And by the way, this is another kind of shout out to our awesome community team, the community engineering team here at CircleCI. These are folks that are actually, building the community level type software, things like orbs, right? Our convenience images, which are these images that are provided by the node image, right? These are the awesome people that are doing all of that awesome work. It's very hard work. We're definitely interested in sharing their work, which you'll see a lot more demonstrations from me, of course. So let's go ahead and start with this new config. Yes.
Apologies for interrupting. There's a question in the comments about where to find this config if folks want to have a look. And I just wanted to point out that one of the the link that one of the folks watching is actually the exact right link. So they link to the blog post that you mentioned.
Yeah, that's
that was published earlier today. And I just wanted to say that if you scroll all the way to the end, there's a link to the GitHub repo, and you can just kind of fork it, and you will have all the code if you want to follow along and make these changes.
Yeah, for sure. Well, you'll have the blog post code, but this is more like stuff that I've and maybe I'll update that repo as well with maybe a branch, or we'll figure it out. But yeah, I'll make this available as well in the orb usage. So and thanks, Jeremy. Jeremy is one of our coworkers at CircleCI. So if you can post some other links, that'd be awesome, buddy. Appreciate it. All right, so. The first thing I want to do is, if you're ever interested in learning about orbs, I'm going to show you real quick, if I can find my windows. I'm jumping around a couple things here. All right, here we go. So first thing you want to do is just do circleci.com, and you can say like orbs. And this will give you kind of like, where's the registry? I guess this is it here. Well, that's okay. This is the registry for our orbs. So you can go to CircleCI developer /orbs. This will get you to a search box. I want to check on the version. I believe we're at 2.0. Yep. So here's a Terraform orb that I was talking about. We recently updated it. So what you could do here is, let me plus that up a little bit. It's kind of, maybe that's too much, but all right. So basically, right, this will tell you how to use the orb. Give you some example about the jobs and apply, right? So first I want to get is this version number here. So we're going to paste that, and then we're going to go back to our code. And I want to go ahead and, no, not that way. That one this one we're going to keep, and I'll paste that there. This one I'm going to I'll just delete it. We don't really need it anymore. So when you're developing orbs, this is a good example of how you would like test your own. But by the way, you can contribute to the community orbs. So if you're interested in creating your own functionality and sharing it with the community, you could do that as well, which I highly encourage and often support directly. So along with our CPE team. So yeah, go ahead and change that. So now we have basically 3 orbs that we're using, right? The initial orb, which is fine, right? We're kind of familiar with that one. This Terraform orb, again, is something that we at CircleCI have created, and we maintain it. And then also this Docker orb. So anything with this CircleCI namespace here is stuff that we create and maintain for our community. And so these are the 2 new additions, right? The Docker orb and the Terraform orb. So the run test really hasn't changed much, so I'm not going to go through that one. But what we have here is the build Docker image job, right? So remember in the previous Docker image job, without the orb, we had some manual steps here. But look how much cleaner it is now, right? So now that I've instantiated the Docker orb, or imported the Docker orb, I want to do a Docker check, which means basically, ensure that the bits that we need are installed, everything's kind of good to go. And then you could just jump into executing commands like build, right? And of course, we want to give the Docker build a name, which is right like this image name, and then we also want to add tags, right? So that remember I had built that variable and exported it in my job. Now I could just assign it directly to the value without having to do all that jump through hoops kind of thing process, right? Then finally, right, I want to push it. So once it's built, we have a simple command, and isn't that much cleaner than the previous one, which I think is again lends itself to being a little bit more concise, and the reusability is phenomenal. So that's our Docker build image, right, with the orb, which is defined up here. We're using version 1.5. And real quick, if you ever have to go back to the registry and figure out, like, let's say maybe you want to do Docker here, right? Sorry. You can check what versions. So I mentioned we're using version 1.5. You can actually click this drop down and see the previous version. So we want to maintain some semblance of backward compatibility, which is really important, right? We don't want to introduce breaking changes. We want to introduce innovation, right, and evolution to the orb. So yeah, you can pin these, right, and it's a very structured process that we do at CircleCI to ensure that with adding new things, we don't introduce a lot of breaking changes, because that's bad. So great. So let me jump back over, because I'm sure people just want to see this thing work. But I just wanted to show you how I'm leveraging the Terraform Orb, right? So remember, I had a custom command key that's no longer in existence in this pipeline, right? I don't need it. And the reason is we have the Terraform Orb. So let's jump down into our deploy AWS ECS, which is what we basically talked about earlier. So as you can see, it has an install capability, right, or function. And here we're just basically telling it, again, the version of Terraform, more importantly, the architecture, right, that we're targeting. And then now we have the operating system, which is Linux. So what the orb does is essentially almost the same thing that I showed you with my custom built parameter variable, but has a little bit more flexibility to it, because you can now define the operating system. The other one just defined a Linux one, right? So that was static and kind of hard-coded. So the next bit, right, is the Terraform init, right? So initializing it. And obviously, you need to tell it where the code lives. And again, right, we have a plan here. This is essentially just kind of doing a pre-check. So it builds a graph of the infrastructure it's going to build. For CI, I don't think this is very relevant, but I kept it in here just to kind of show the folks who use Terraform manually, right? You could still do these things. Me personally, I would eliminate this step, but for the purpose of the demo, I included it. And then we have the workspaces, which essentially is if you're running things locally, you could have multiple configurations and state files running in workspaces. We're using Terraform Cloud, so our workspace is going to live in the Terraform Cloud service. So this is kind of irrelevant, and we'll just leave it blank, right? And then finally, right, remember that apply command? This is exactly the same thing, but in orb form. And our environment variables are just basically become a list of things, right, to include. Remember the Docker image name variable, and I want to equate that to the CircleCI project repo name, which is the image name that we built. And this is what's going to be deployed, right? So let's go ahead and just jump into it. All right, maybe show you the workflow real quick. So, workflows orchestrate jobs. So as you can see in our build, we want to run our run test. We want to execute our run test job. And then we also want to build a Docker image. And then we also want to deploy, right? So I am going to run these three in parallel, right? The reason is I believe in running as efficiently as possible. I'm sure Alexey will agree, right? Like we want to be optimal and do things concurrently as much as possible. I really don't like dependencies personally. So these are things that kind of help with keeping your build durations as minimal as possible. So Alexey, let's go ahead and update our app, right? So this is the application. So I want to demonstrate here. I don't have a version. Wow, okay. So I thought I had a version number here. Actually, what we could do is maybe just add, I don't know, we'll add a comment here. So where's my message? Let me see. All right, so I'll add a comment here. Add a version number, call later. Wow. As you can see, my typing skills are the best. There we go. All right.
Always typing the best way under. Good.
Yeah. No, I'm the worst. Even without the live stream, right? Like it's a running joke in my house. Like my kid is like, "Oh, you've been in this industry for so long and you still can't type." Yeah, that's right. But at least I own it, right? So I'm gonna save this. Made some code change, right? So what we're gonna do now, normally I do this in the command line, but I'll just, for demo purposes, speed this up. I'll just say added a comment, right? And then we're gonna go ahead and push it. So this is a good way to show people how to do this in the code editor as well. Or did I not push? Oh, right. I need to first. There you go. Commit. Didn't commit. Always commit before you quit, and then push up. So the cool thing now is that I wanted to show you is, let's go to our, I think I need to change my organization because I have multiple organizations. And in this case, it picked up my code change, right? So now if we jump into that pipeline, now remember our build pipeline, let's go back one. Our build pipeline is number 51, right? So it's executing my code. You see how fast it picked up the change. I'm running, right, those 3 jobs concurrently, because you should, wherever you can, eliminate any kind of dependency. And what's going to happen here is, in a few seconds, I anticipate the run test job will turn green. The longest bits here are going to be deploying to AWS ECS. It could take a few minutes, but as you can see, we have our run test actually built on the ARM Linux Medium, right? So you can see right there what your executor is. It has 2 CPUs, 8 gig of RAM, totally ample enough hardware to run this particular job. Don't you agree, Alexey? It's most of the time medium and large are suffice for these types of works, right? Or jobs, right. Workloads.
Yeah, we usually recommend starting with medium, and then if you want more memory, more CPU, then just gonna go up from there. But usually the medium is the starting point.
Right, and what's a good point too? Like, so what tends to happen is, these pipelines will run, and they're like, look, this one finished in like 35 seconds. Great, good speed, right? I like to have a 1 minute, 60 second, under 60 second, job duration. But once you start seeing those creep up, because it will, right? Your code's going to grow, and that will impact your compilation, your build processing, and all that stuff. An easy tweak is to just, give the build more resources, right? And it's just a value change in your config, rather than having to go through your application and maybe even, instantiating some concurrent testing, which you should be doing that, but sometimes you don't have enough time or enough resources to do that. An easy tweak would be, hey, give it some more horsepower, and that should get your builds right. It should at least help get them in line to where you either were or you are targeting to have build durations, last, or the durations are within the range of your acceptance.
Exactly. I would say that for many applications, the speed up is not always going to be 2x, right? So if you kind of double the amount of memory in CPU, it's not always going to be 2x. So it's rarely is going to be exactly, perfect scaling on that front. So it's, I would just say it's important to try out a few different options, just see what is the best balance for you of, how long are you okay with waiting for this to run compared to, the fastest possible option, but also watching your budget, making sure that you are not kind of overspending on something that you should be running on maybe smaller containers, right? And just kind of finding the right balance for you and for your team on kind of what you run on which resources there.
Yeah, I mean, one of the things to take away from this is always be watching your pipelines, right? Like, this isn't it's not a set it and forget it. If you want to maintain a certain velocity in your CI processes, you definitely need to maintain vigilance over your build durations, right? Just the pipeline in general and the health of it. One of the things I'm going to show real quick is that, as you can see, our deploy AWS ECS job has completed successfully, which is always good when you see those green bits. I actually am a big fan of the red failures because that kind of tells you what's happening, right? But as you can see, right here's a kind of a little, outline of what happened. In our code, we've installed the binary, and you can actually see the end result of like all those, values that were implemented. So this Terraform version was a parameter. This operating system, Linux, this guy here was a parameter, and then obviously the architecture, right? So you could see where that orb just injected those values really easily into the pipeline config. Obviously, the apply bit. Actually, let's take a look at the plan. So I was showing you. There's the graph, right? So this guy is telling you, hey, we're going to create 29 resources in Amazon, which includes a VPC, includes all the things you need, right, to get an ECS cluster up and running, an isolated cluster. So let's go into Amazon and check out what is going on there. Elastic Container Service. You can see I have my ARM, app ARM version 8, right, running. Now, again, this was all created from that Terraform code. If you dig into there, let's take a look at what's underneath, which is the ARM Graviton instances. There should be 2 of them there. I'm not sure why there's only 1, but maybe there should be 2. But we'll take a look at that in a sec. But for the most part, right, let's take a look at that instance. What we're running is an ARM Graviton. So this T4G is the designator for, is that Graviton, right? In Amazon, I believe that's right.
Yeah, exactly. So the once again, T4G. Yeah, T4G. The G in there is the identifier for Graviton, effectively, and they have a few families. So T4G is one, and then C6G, I think, and then M6G and a bunch of others.
Right. So the G is the Graviton
exactly.
designator. All right, that's cool to know. I thought that was the case, but you have a lot more extensive experience with that than I do. So for some reason, we only have, let me see, maybe, yeah, okay. So the auto scale bit takes a little bit longer, even though Terraform said it was fully operational. As you can see, it added a new instance. So again, this is like fully operational right out the box with the Terraform. With auto scaling, it also has a watch, right? So like if anything happens and any of the thresholds for my alarms are exceeded, then the auto scale group will plus up 1 and then destroy, or just plus up in general. So as you can see here, there's a running task. This means there has a container or application has not been deployed to this resource yet. If I do a refresh, there you go. I have 2 running tasks on 2 different nodes. Now, let's go ahead and take a look back at our pipeline, because that's what we're really focused in on here. So I have this pipeline that completed. The last thing I want to look at, though, is the application, right? Live. Let's go see what that looks like. Now, with a load balancer in Amazon, right? They give you a domain name, essentially a subdomain, right? Based off the load balancer and the resource that they've allocated on Amazon. So you can basically hit this endpoint at this address. Oh, let me copy that properly so I can get it. So let's go ahead and check our application. Let me plus that up a little bit. So we can see that our application is actually running in ECS on a ARM Graviton 2 ECS compute nodes, right? So this is kind of like really cool and amazing for me, because now our developers can expand their products to ARM capable architectures, right? Which is really important. Now you have a new kind of market and community to even offer up your your applications. Now, it's really important though that, while I was building this out and with my experience over the years with ARM, you have to ensure that your binaries, the things that you're releasing to the public with your products, are ARM capable. And this is one way to kind of, build that into your CI/CD processes. And by the way, this workflow, you could actually, or these jobs, you could actually run, things in Linux for specific jobs. It doesn't have to be an all ARM. This is an all ARM end-to-end thing I'm showing you, pipeline I'm showing you. But right, Alexa, you can just mix and match within your pipelines, within your workflows, those different executors. So like, if you want to test, ideally you would have more jobs, right? That would be like, let's jump into this one. Ideally, you would like jump into this, right, and have like maybe build Docker image for ARM, build Docker image for Linux, all those cool things. So now that we have our application ECS running, what I did want to show though was, like the not the load balancer, but the auto scale groups, right? So again, right, we created this app ARM scale group. I have two nodes. Again, these are the ARM Graviton instances that I'm using and configuring, all in one shot. Now, the cool thing with this is, ideally, we're just showing off how you can leverage the power of orbs, CI/CD, or CI/CD orbs, and then the Graviton infrastructure and architectures. But let's say, we run our test on that ECS. There's maybe some more tests to run, and we want to destroy this. Right now I have a manual approval. So by clicking this, I can actually tell my pipeline to destroy all this infrastructure that was created, right? So this is ideal for like maybe in your software development processes, you want to promote this release into a Q&A or something. But before you would do that, you want to do some automated testing after deployment. This is perfectly fine, and I highly encourage you to do that. But you can easily implement, using infrastructure as code, you can easily implement those kind of pipeline jobs, right? That will help you automate a lot of that stuff, so you're not sitting there manually testing things as a lot of folks actually still do. So before I click that button, let me show you what that looks like in the config, right? So essentially this workflow here, right, we created a job in the workflow called approve destroy. We have a type called approval. So this is basically a manual step, right? This designates the pipeline to stop, and it will not continue until a manual action is taken, which in this case is clicking the button in the UI. So this is for like use cases if you have some requirements where, maybe a manager or a group of maybe security teams or someone who has some responsibility over releases has to review things, make sure things are in order. You can stop it. You stop the pipeline, have them come and take a look, and then once they click the button, it will kick off, right, this destroy AWS ECS. And the reason why, the way it's tied to this manual approval process is we've got the approve destroy, right? So this approve destroy has to be clicked, and then the destroy AWS ECS command will be triggered. And obviously, right, the approve destroy button will not be enabled until the ECS cluster has been deployed. So this step has to be complete before the button becomes actionable, if that makes sense. Yeah. All right, cool. So sometimes this can get a little bit confusing for folks, but once you start living and breathing pipelines, this becomes old hat, second nature. So finally, let's go ahead and destroy all this beautiful infrastructure that we created. Hopefully it takes way less time than it did to create, which wasn't that much, by the way. I got to say, I was impressed with all the resources that we created. It's a lot of things going on and a lot of orchestration happening. So the amount of time it takes to build that stuff using infrastructure as code is pretty amazing. So if you look here, let's take a look at the running. I want to see how long this one took. 3 minutes and 19 seconds, right, in total. That's pretty damn good for building a whole infrastructure based on Amazon, again, VPC, security groups, creating roles, creating auto scale groups, creating elastic load balancers, creating the ECS cluster, and then also deploying the application. That's not a bad time, right, to build that software.
Right. Angel, we have a quick question here.
Yeah.
What happens when there's another pipeline starting kind of to run in parallel to kind of, if you haven't hit the approve button? I think I'm getting the question right here. If you haven't hit the approve button and the job is kind of waiting on that approval stage, what happens if you run another pipeline, right? What happens then?
Yeah. So what'll happen is the application will be deployed to the infrastructure. So the state is being saved in that Terraform Cloud. The next run of this pipeline will have access to that state, and it'll, basically pull that in. And then if all of the things that, in your infrastructure's code have been created, it will only work on, or it will only deploy the things that have changed, which would be a task definition, which means probably your image, the image name has changed. So then it will deploy that new image. So until you click this button, it will not destroy the cluster. Does that make sense? So normally if you had, let's say that button didn't exist and you had to replace that with like a test deployment or something, it would automatically, right? If it passed, it would automatically destroy that cluster. But you can in the middle of all that, if you create a new cluster, depending on how you're managing the state, I have it so that it's locked while Terraform is working, so nothing can change. Your pipeline will fail because the Terraform will say, "Hey, I can't do anything. It's locked, right? That state is locked." But once it's completed in the previous builds, then you can rerun the previous pipeline that failed, and you should get the results you're looking for. But you could also do things in Terraform code that rename, so it'll create a whole new infrastructure, right? Depending on how you want to do it. So there's a couple ways to do it. This is a demo. This is not ideal by any means in production or whatever. It's just an example to show folks how how you can leverage this to use infrastructure as code and deploy applications to target environments, right? I'm a firm believer in deploying your releases prior to promoting them, because you want to, do some kind of cursory smoke testing on that stuff to ensure, like, hey, is this thing responding? Critical things, testing the easy critical things, because if you're not getting a response from a deployed app, what's the point, right? Like, it's pretty much trash. So hopefully that makes sense. So I think, we're a little bit over. Any other questions or comments? If not, I think we kind of did. Let's test and see. This should be, it's not responding anymore. We can check for our ECS cluster. Hopefully that's still around, but let's see if we have any nodes. It tears down slowly because there's a lot going on. These haven't gotten to be destroyed yet, but our application is definitely not responding, right? And eventually this will redirect to Amazon. Other than that, Alexey, do you have anything to add?
No, basically the one thing that's kind of cool. So the code that you have been, the code that we started with, right? Not after the changes, but before your changes, is kind of, as you mentioned, available in the blog post that Jeremy has linked to previously. Jeremy also was very kind to place the link to the CircleCI docs that you can check out.
Right there.
Yeah, exactly. I was just going to say, this is the link if you want to go and look at some simpler snippets potentially for just getting started with ARM, as well as the link to the forum where you can get access. This is the location, right? So just go on, check it out, and kind of let us know if you have any questions over at the Discuss forum, or raise a support ticket if you have further questions. If something doesn't work, you can always reach out to our support team and they will help you out.
So great point though. Again, we need to mention that you need to sign up for the preview access. So again, all of this stuff is available in the documentation link that you're seeing here from from our friend Jeremy. And then also I'll show you the link to the blog. So here again, our friend Jeremy hooked us up with that link. It's really hard. I'm managing all of this. I feel like, kind of an amateur TV producer, show producer, whatever. But the software makes it pretty easy. But yeah, thank you, Jeremy, again for supporting. Appreciate it. But yeah, if you need to reach out to look at the blog should have all the links, right? And again, if you need any help or want to comment or even contribute, definitely start using the ARM capabilities and giving us feedback, because we're here to build again useful products for our developers so that they can just focus in on their code and not have to worry about all the other stuff that kind of gets in their way, right? Trips them up for supporting their applications and building their applications. With that said, Alexey, do you have any parting words for our audience?
No, not really. Thank you so much, Angel, for running through the demo. That was super interesting to just kind of run through it end to end. It was super helpful. Thank you so much.
Oh no, thank you. And let me get this out of the way. So so I just wanted to say thank you, Alexey, for taking the time. I know it's super late. I apologize for that. Where you're at, and I will say this: Alexey is always down to support, and he always answers questions in the middle of the night sometimes. But I really appreciate that. Yeah, you answered mine, so I don't know. Maybe okay. He doesn't do that. Everyone else, he doesn't do that. I promise. But no, thank you so much for supporting this, and again, and actually producing this. This is you and your team have done an outstanding job here, and I look forward to building some more ARM architecture or infrastructure on ARM architectures. It's really important that we provide these services and features to the community.
Thank you. And likewise, thanks so much for setting this up. And on the ARM side, we're looking forward to having more customers join the preview and start running on ARM and deploying to ARM and so on.
Absolutely.
Thanks so much for watching.
All right. Thanks.